Welcome to the deep dive. So today we are looking at a stack of articles and some technical documentation exploring Vaadin.
Yeah, Vaadin.
Right, which is a framework that is, well, it's completely flipping Java web development on its head.
He really is.
And our mission for this deep dive is to see if unified server-side coding is actually a viable future for the web. And to understand exactly how Vaadin manages to bypass traditional front-end languages entirely.
Right, because that's the big claim here.
Exactly. So to really grasp why this matters, imagine trying to cook a massive complex meal for a dinner party, right?
Okay.
But your kitchen is completely chaotic. You have to speak 3 different languages just to get anything done.
That sounds awful.
Right. So you speak Italian to operate the stove.
Okay.
And we'll call that Java. And then you have to speak French to get ingredients out of the fridge.
Right, which is JavaScript in this analogy.
You got it. And then you have to speak German just to turn on the sink. So that's your HTML and your CSS.
It sounds like an absolute nightmare.
Yeah.
And it's a perfect illustration of the mental toll that context switching takes on software engineers. Because we have somehow universally accepted this highly fragmented approach as the standard way to build the web.
Yeah, we just accept it.
Right. You have your back-end logic operating in a secure server environment with one language, and then a completely separate ecosystem of technologies handling the user interface in the browser.
And you are constantly bouncing between them while trying to, keep the big picture of the application in your head.
Exactly.
You pull the data out in French, you process it in Italian, you render it in German.
Right.
It's a recipe for drop data and basically burned food.
Burned food, yeah.
But the documentation we are diving into today outlines how Vaadin promises a unified language environment. So no more French fridge, no more German sink, just Java.
Right.
Start to finish, back end to front end.
Which is a massive paradigm shift. It allows developers to build robust web applications without that cognitive drain of juggling multiple tech stacks.
Okay, but let's pause and really look under the hood here.
Sure.
Because the skeptical engineer in me is waving a massive red flag right now.
I bet.
Because web browsers like Chrome or Safari, they fundamentally do not understand Java.
Right.
They render HTML, they parse CSS, and they execute JavaScript. That is the universal language of the browser.
That's right.
So if a developer is using Vaadin and writing absolutely zero HTML or JavaScript, how does the browser know what to draw on the screen?
Yeah.
Is the server just beaming pixels over the network?
No, it's not beaming pixels.
Yeah.
But it is taking control in a way that feels almost like telepathy.
Okay.
So what we need to understand is the underlying server-side architecture. The browser is still getting exactly what it needs.
Right.
The HTML, the CSS, the JavaScript. But the developer isn't the one manually writing or managing it.
I see.
Vaadin acts as this incredibly sophisticated engine that sits between your Java code and the browser.
Okay, I need to understand the mechanism there. Are we talking about a simple template compiler that just spits out static HTML pages?
No.
Because that, as 1990s web development,
Yeah, no, not at all. It is highly dynamic. When you write your application in Vaadin, you are building a server-side representation of the user interface.
Okay.
So think of it as a virtual DOM tree, but it lives entirely in the server's memory.
Oh, wow.
Written in Java.
Just in memory.
Yeah. So when a user navigates to your applications, Vaadin takes that Java UI tree, generates the corresponding lightweight HTML and JavaScript, and then sends it to the browser.
Wait, hold on.
Yeah.
If the server holds the entire DOM tree in memory for every single active user session, doesn't that become a massive memory hog?
Right.
If I have 10,000 concurrent users, my server is keeping track of 10,000 distinct UI trees.
That is a very valid architectural concern.
Yeah.
And it's actually one of the primary trade-offs of the server-side model. Yes, the server maintains the state for each user session. However, these Java objects representing the UI are heavily optimized.
So are they?
Yeah, they're incredibly lightweight.
Yeah.
Modern JVMs, so Java Virtual Machines,
Right.
they can handle millions of these objects with highly efficient garbage collection.
Okay, so it's not as heavy as it sounds.
Right. So while the memory footprint is higher than a purely stateless REST API,
Yeah.
it is well within the capabilities of modern enterprise server infrastructure.
Okay, so the server has the map of the UI,
Right.
but modern web apps are highly interactive. Users are clicking buttons, they're opening modals, typing in text fields.
Yeah.
If the developer didn't write any JavaScript to handle those events, how does the browser tell the server what the user is actually doing?
Right, so that happens through a seamless bidirectional communication channel.
Okay.
Typically, it utilizes WebSockets.
Ah,
Yeah,
WebSockets.
Vaadin automatically sets up a WebSocket connection between the browser and the server,
Just right out of the box.
right out of the box.
Yeah.
So when the user clicks a button, a tiny JSON payload is instantly fired over that WebSocket to the server.
Okay.
The server receives it, triggers the Java event listener that you wrote for that button, updates its internal server-side DOM tree,
Right.
calculates exactly what changed, and then pushes a highly compressed diff back over the WebSocket to patch the browser's DOM.
So it's essentially acting like a remote-controlled drone.
Oh, that's interesting.
Like the pilot, meaning the server, right? It has all the intelligence, all the decision-making power,
Right.
and the control logic.
Yeah.
And the drone itself, the browser, is relatively dumb.
Exactly.
It merely executes the physical movements and sends back raw telemetry like clicks and keystrokes.
That is a much better way to conceptualize it.
Yeah.
The browser just becomes a thin rendering client.
Okay.
And if you think about the implications of that for a developer, it's massive.
Oh, I bet.
We talked about context switching earlier. Imagine trying to trace a bug in a standard single-page application.
Oh, man, yeah.
You start with a SQL query, you trace it through your Java backend, across a JSON API payload,
Right.
into a JavaScript fetch call, and finally figure out why a React component isn't updating.
It's exhausting. I mean, half your day is just figuring out which side of the invisible wall the bug even lives on.
Exactly. But with this unified drone model, that cognitive drain just vanishes.
Because it's all in one place.
Right. You write your business logic in Java, and in the exact same file, you can write the code that updates the UI in response to that logic.
Wow.
You are using the exact same debugging tools, the exact same mental models, and the exact same testing frameworks for the entire stack.
And I imagine that opens up a lot of doors regarding the Java ecosystem itself.
Oh, absolutely.
Because Java powers everything from high-frequency trading platforms to, complex machine learning pipelines.
Right.
And typically, exposing those capabilities to a front end requires building out really complex intermediary APIs.
Precisely. Because you are staying entirely within Java, you certainly have direct access to Java's massive existing ecosystem of libraries.
Right from the UI code.
Right from your UI code. If you need to hook a button, click directly into an Apache Kafka event stream,
Yeah.
or utilize a heavy cryptography library, you just import the Maven or Gradle dependency and call the method.
That's it.
That's it. There was no API translation layer required.
That is huge. Let's pivot to the actual workflow, though.
Sure.
Because practical productivity is a huge part of what we are analyzing today.
Right.
So if I'm a front-end developer transitioning to this, I'm used to writing HTML to define structure and CSS to handle the layout. In Vaadin, am I just typing Java code into a blank screen to build a UI?
Well, you are writing Java, but you aren't building from scratch.
Oh.
Vaadin ships with a comprehensive library of web components out of the box.
Oh, nice.
And we aren't just talking about basic text inputs and buttons here.
What kind of components?
We are talking about highly complex data grids, interactive charts, date pickers, layout managers.
But how customizable are they? Because one of the biggest complaints with massive UI component libraries is that the second you need the component to do something slightly outside of its default behavior,
Right.
you just hit a brick wall. And you end up having to hack the underlying code anyway.
I know exactly what you mean, but that is where the architecture actually helps.
Or so.
Because these components are backed by a Java API, you customize them programmatically using object-oriented principles.
Oh, I see.
So you instantiate a new grid object, bind it to a Java data source, and configure its columns, sorting, filtering,
All in Java.
all through strongly typed Java methods. You aren't hacking CSS or overwriting JavaScript event bubbling.
Right.
You are just calling methods on an object.
Okay, I see. And because it's standard Java, it integrates perfectly with standard tooling.
Exactly.
Like the documentation notes this tight integration with IDEs like IntelliJ IDEA and Eclipse.
Yes, it's very seamless.
So you get auto-completion, refactoring tools, and compile time error checking for your user interface.
Right.
Which is wild. Like if you mistype a property on a UI component, the code literally won't compile.
Exactly, yeah.
So you catch the UI bug before you even run the app.
Yes. The compile time safety is a huge productivity multiplier.
For sure.
But the tooling goes even further to accelerate the development loop.
Okay.
One of the standout features highlighted in the docs is their approach to live reload.
Ah, live reload.
Yeah,
Yeah, that is practically a baseline requirement for modern web dev.
it really is.
Like making a change, saving, and instantly seeing the browser update without losing your place is critical.
Right.
But hot module replacement in JavaScript frameworks is notoriously finicky.
Oh, definitely.
So how does Vaadin handle it if the UI is running on a compiled language like Java?
Well, it leverages JVM hot swapping.
Oh, interesting.
So you modify your Java UI code in IntelliJ, you hit save, and the JVM instantly replaces the modified classes on the running server without restarting it. Yeah, and then the server pushes the updated UI state to the browser via that WebSocket connection we discussed.
So it's immediate.
The browser updates in real time, instantly.
So you get the rapid, instant feedback design loop of a client-side JavaScript framework, but you are writing strictly typed, compiled backend code.
Exactly.
That is a very compelling combination.
It is. But if we're talking about the real productivity killer in modern web development,
Yeah.
we have to talk about distributed state.
Oh, managing distributed state across the client and server.
Yes.
That is usually what causes those late-night debugging nightmares.
Always.
Trying to keep a Vuex or Redux store in the front end perfectly synchronized with a relational database on the back end via a REST API.
It is arguably the most complex part of building a single-page application.
Yeah, it's a huge pain.
Because you have a split brain, you have the authoritative state on the server, and you have a temporary optimistic state in the user's browser.
Yeah.
So developers spend countless hours writing complex synchronization logic, handling race conditions, dealing with stale data.
Yep.
If the browser thinks an item is in the shopping cart, but the server dropped the API request.
Your application's just broken.
Exactly. It's out of sync.
And Vaadin bypasses this entirely because of the drone architecture.
Exactly. Vaadin eliminates the distributed state problem because state only exists in one place.
The server.
The server.
So the browser truly has no memory of its own.
The browser only knows what the server tells it to render at that exact millisecond.
That's wild.
If a user modifies a complex form, the state of that form is updated directly on the Java server.
Okay.
You never have to write code to synchronize a client-side data store with a back-end database.
Yeah.
Because the client-side data store literally does not exist.
But wait, I have to challenge that.
Okay, go for it.
If every single interaction, every form input, every checkbox requires a round trip to the server to update the state, doesn't that introduce massive latency?
That's a good point.
Like, if I'm a user on a slow 3G mobile connection, is my application going to lag every single time I click a dropdown?
That is the Achilles heel of the server-side model.
Yeah.
And it's a critical point to address. Yes, latency is a factor.
Okay.
Now, Vaadin employs several techniques to mitigate this,
Like what?
like intelligent debouncing of text inputs and keeping certain purely visual interactions localized to the client side.
I see.
But fundamentally, if the network connection drops entirely, the application stops working.
Right.
It is not designed for offline-first applications.
So if you were building an app for field workers who go into subways or remote areas with no cell service, this is just not your framework.
Correct. But for the vast majority of enterprise applications,
Yeah.
Internal business tools, complex administrative dashboard.
Right, where a stable internet connection is just assumed.
Exactly. For those, the trade-off is almost always worth it.
Okay.
You are trading a slight dependency on network latency for the complete eradication of state synchronization bugs.
Which transitions us perfectly into why large-scale organizations actually prefer this model.
Right.
Because when we look at enterprise software, banking portals, healthcare data management, human resources systems,
Huge systems, yeah.
productivity and developer experience are great, but security is paramount.
Absolutely.
I mean, a fast development cycle means absolutely nothing if you leak sensitive patient data.
Right. And this raises a fundamental discussion about API surface areas.
Okay.
In a modern React or Angular application, you are essentially forced to build an extensive REST or GraphQL API to serve data to the front end.
Right. You have to.
Every single one of those API endpoints is a potential attack vector.
Right, because you have to secure the endpoint, you have to manage authentication tokens, ensure rate limiting, and constantly worry about overfetching data.
Exactly. And furthermore, you are shipping your routing logic, your validation rules, and the entire structure of your application to the user's browser. Anyone with technical knowledge can just open their browser's developer tools and reverse engineer exactly how your application communicates with the database.
I've actually seen that happen.
Oh, yeah?
Yeah, a developer accidentally includes a hidden admin field in the client-side JSON model,
Oh, no.
assuming that because it's hidden in the UI, it's safe.
Right.
But a malicious user just inspects the network traffic, finds the hidden field, and exploits it.
That is a classic vulnerability.
Yeah.
But with Vaadin server-side approach, there are no REST endpoints to hack.
Wow.
There is no API surface area exposed to the public internet other than the initial page load and the WebSocket connection.
Because the communication is just opaque UI sync messages.
Exactly.
The browser is just receiving instructions like, draw a button here and sending back button clicked.
Precisely. The application logic, the business rules, the sensitive data, it all remains safely behind the firewall on the server.
Right.
The client never sees the raw data model, only the rendered representation of it.
So you simply cannot reverse engineer the business logic from the browser's network tab because the logic just isn't there.
Exactly. It's just not there.
That makes total sense.
Yeah.
I mean, it inherently mitigates entire classes of vulnerabilities.
Oh, yeah.
Like certain types of code injection or insecure direct object references simply by never letting the data leave the server environment.
It creates a massively reduced security footprint.
Yeah.
And this is why large enterprises gravitate towards it. They get the...
Like, do you have to write a completely separate Java application for the mobile view?
No, not at all. And this is where the sophistication of the component library really shines.
Oh, okay.
The UI components provided by Vaadin are built with responsive design baked in.
Oh, really?
Yeah.
So a complex multi-column data grid on that 4K monitor knows how to gracefully collapse into a touch-friendly single-column view on the smartphone.
Yes. The components utilize CSS Flexbox and grid layouts under the hood.
Ah, okay.
So while the developer is writing Java, the framework is ensuring that the generated CSS includes all the appropriate media queries and responsive behaviors.
So you just build the application once in Java, and it automatically adapts.
Exactly. Build once, run anywhere.
Nice. I'm assuming there's also an ecosystem of support required for enterprise adoption.
Absolutely.
Because a Fortune 500 company isn't going to bet their core infrastructure on a framework unless there are guarantees of longevity and support.
That is a crucial factor.
Yeah.
The documentation emphasizes that Vaadin isn't just an open source project managed by a loose collective.
Right.
It has commercial backing. They provide long-term support releases, or LTS.
Okay, LTS.
Which means enterprises can standardize on a version and receive security patches and updates for years without being forced into breaking architectural changes.
Which is a stark contrast to the JavaScript ecosystem.
Oh, tell me about it.
Where it feels like a framework is completely overhauled or just abandoned every 18 months.
Yeah.
Leaving development teams scrambling to rewrite their applications just to stay secure.
The fatigue is very real in the GS world.
Yeah.
So having a stable, commercially supported foundation, coupled with a very active community, provides that necessary safety net for large-scale adoption.
Well, this has been a truly fascinating exploration.
And it really has.
To kind of synthesize what we've unpacked today, we've looked at how Vaadin fundamentally challenges the modern client-server divide. Right. By acting as a sophisticated engine that maintains a virtual DOM on the server and pushes lightweight updates via WebSockets, it allows developers to build interactive web apps entirely in Java.
Right.
It drastically reduces the cognitive load of context switching.
Which is huge.
Yeah, and it eliminates the nightmare of distributed state management by keeping the application's memory localized to the server.
Exactly.
And crucially, it vastly improves the security posture by never exposing business logic or raw API endpoints to the client browser.
It really highlights a core engineering principle for me.
What's that?
Complexity is often the enemy of both security and productivity.
Right.
By intentionally removing layers of the technology stack, Vaadin inherently makes the entire system more robust, easier to reason about, and just faster to develop.
Absolutely. And for our listeners, whether you are architecting a massive internal tool for a global enterprise or just evaluating tech stacks for a complex startup idea, the takeaway here is really about stack consolidation. Minimizing the number of distinct technologies your team has to master isn't just about convenience.
No.
It is a strategic shortcut to shipping features faster and keeping your beta more secure.
Because when you aren't distracted by the complex plumbing of synchronizing data across a network boundary,
Right.
you can focus your engineering hours on solving actual business problems.
Exactly.
Okay.
And that brings me to a final thought I want to leave everyone with.
Okay.
The documentation we reviewed explicitly praises Vaadin for allowing developers to build without the distraction of managing specialized front-end languages.
Right.
It completely abstracts away the browser's native tongue.
Yeah.
So here is something to ponder as you evaluate your own tech stacks.
Let's hear it.
If server-side frameworks like this continue to evolve, leveraging things like WebAssembly and increasingly intelligent WebSockets to seamlessly orchestrate the client-side experience, what does the future hold for specialized front-end frameworks?
That's a good question.
Are we eventually going to reach a tipping point where a single unified back-end language truly rules the entire development stack from the database to the pixels on the screen?
Wow.
Or will the ever-increasing demand for complex, offline-capable, highly animated user interfaces mean our development kitchens will always require at least a little bit of translation?